Quiet, please. All right, so again, this is polynomials. And again, this section, there's not a lot of work here. It's just vocabulary and definitions. So the first definition we need is a definition of a monomial. A monomial can be a number. So it can be a number. Let's see if I can write a little neater. So it's a number, a variable, or it can be the product of those. It's kind of a long definition. Or the product Ethan? A number. All right, so it's a number, a variable, or the product of a number and a variable. I cannot write today. With whole number exponents. All right, let's see if that makes sense now. So again, it's a number. So a monomial is a number, variable, or the product of a number and a variable with whole number exponents. So we've got some examples down there for 1, 2, and 3. All of those are monomials. So if you look at these right here. So 1, 2, and 3, those are all monomials. Monomial means there's one term, okay? Terms are separated by addition and subtraction. So these are all one term because they are really a product of factors. Do you see that there's a multiplication like right here between the 4 and the p to the 4th? And also between the p to the 4th and the q to the 3rd. So when it's all multiplication like that, when it's just a product of factors, that's all one term, okay? Terms are only separated by addition and subtraction. And one term would be a monomial. So now the next thing it says is we got to find the degree of these monomials. So if you look at, well, they have a definition of it right there. It says the degree is the sum of the exponents. Well, it's the sum of the exponents on the variables, okay, not on the numbers themselves. Ethan, stop, please. So it's the sum of the exponents of the variables. So I'm going to add that onto this right here. It should say sum of the exponents of the variables. All right, so we got to find the degree. So the first one, number 1 here, the degree is equal to, well, what's the sum of the exponents on the variables? Yeah, so it's just 4 plus 3, so the degree is 7. So that monomial has a degree of 7. And then number 2, yeah, the exponents on the e and the d, e is to the first power and d is to the first power. So if you're going to do the sum of the exponents on the variables, it's just going to be 2. So the second one here, its degree is equal to 1 plus 1, which is equal to 2. And then the third one, well, that one doesn't have a variable, right? Yeah. Or if you want to think of it like this, you could think of it, that's really like 3 times x to the 0 power, right? What's x to the 0 power? Yeah, anything to the 0 power is 1. So it's really like 3 times 1 would just be 3, right? So if you want to think of it that way, that's the only exponent you have on a variable right there, right? Is the 0. So the degree of that one is 0. All right, so then the next thing we got to do is they want the definition of a polynomial. Well, a polynomial is just the sum or difference of monomials. So you just take some of these monomials, like you have 1, 2, and 3, and you, in those previous examples, and you just add those together or subtract them. And that would form a polynomial. So for this, we're going to write the sum or difference of monomials. Come on. I cannot write on this thing today. There we go. So again, a polynomial is just a sum or difference, which means addition or subtraction, right? So it's just a sum or difference of monomials. All right, so then they have some examples here of polynomials. That's numbers 4 and 5. Those are polynomials. And again, a polynomial is the sum or difference of monomials, so it's really a sum or difference of terms, okay? Terms are separated by addition or subtraction. So you can see that number 4 there, that has 2 terms, right? So it has one term here, the 11x to the 7th, and it's got another term here, which is another monomial, that's 3x to the 3rd. And again, they're added together. So when it's going to be a polynomial, it's really going to be the sum or difference of 2 or more monomials. And then the degree of it, they already have the definition for that written out right here. The degree of the polynomial is the same. It's the same as the highest degree monomial. So what you do is you just look at each term and then find the term or the monomial with the greatest degree. That's the degree of the polynomial. So look at number 4. So what's the highest power term there? The 7, right? So that is the term with the greatest degree, is that 11x to the 7th. So then that term is degree 7, so then the degree of the polynomial is 7. So that's degree is equal to 7. Same thing on number 5. Well, what's the degree of, this is a z to the 1st right here, right? Actually, let me do another color here. So there's 3 terms on this one. Do you see that? There's the first term. Here's the second term. Here's the third term. Each of those terms is a monomial. So then we want to find the monomial with the highest degree, and then that degree will be the degree of the polynomial. So you could do like, what's the degree of this first term? Remember, to find the degree of a monomial, you add the powers on the variables. Yeah?
3.
That's 3. So that's degree 3, right? And then this term, again, you're going to add the powers on the variables. So what degree is that? Yep, good. That's degree 4. And then this last term, that's just a constant term, right? That's just a number. What degree is that again? When there's no variable? What's that? Yeah, it's 0. So when it's a constant with no variable, it's just degree 0. So then It's supposed to say degree 3. So what's the highest degree out of those 3 terms? 4. So then that's the degree of the polynomial. So the degree of the polynomial is equal to the degree of the highest power term, or the degree of the highest power, or I should say, the degree of the polynomial is the degree of the highest power term, which is really the monomial with the highest degree. So it's degree 4. All right? We're through most of it. So again, it's mainly vocabulary and some definitions. So standard form, that's our next definition. Standard form is you write the polynomial so that the terms are in order from highest degree to lowest degree. So this should say the terms or the monomials are in order from highest degree to lowest. All right, so that one says the terms are in order from highest degree to the lowest. I guess I could say lowest degree. All right, so then we got to write number 6 in standard form. So what is the highest degree term? You got 4 terms here, right? So which monomial there has the highest degree? Name the whole term for me.
7x.
Yeah, negative 7x to the 5th, right? So that one would go first because we're going from highest degree term to lowest degree term. So we would write negative 7x to the 5th. And then what's the next highest power term?
4x squared.
Yep, that's a positive 4x squared. So we write plus 4x squared. And then what's the next one?
6x.
Yep, then we got a positive 6x. So we write plus 6x. And then what's the lowest degree term?
The 9.
Yeah, the constant term. That's just the number 9. And that's it. All right. So again, you're just writing the terms in order, or the monomials in order, from the highest degree monomial to the lowest degree monomial. And then, this is not in the notes here, but it is in the assignment. Then they also want to know what the leading coefficient is. That's just the number out in front of the whole thing. Ethan, stop, please.
So negative 7?
Yeah. Yeah, so it is the this number right here, negative 7. That is called the leading coefficient. It is just the number out in front of the highest power term. So that's the leading coefficient. Again, one more time, the leading coefficient is just the number that's out in front of the term with the highest degree. All right, same thing on number 7. What's your highest power term? Good, y to the 6th. It's a positive y to the 6th, so we'll write y to the 6th. And then what comes next? Yep, y to the 2nd. That's a positive y to the 2nd, so we write plus y to the 2nd. Again, that positive or that addition symbol, that implies that that y squared is positive. And then the last thing we'd have, well, we only got one thing left, it's the minus 3y to the 1st, right? And our leading coefficient on this one would be a 1. That's the number out in front of the highest power term. All right, and then the last part of this, you just got to be able to name these things. So we got to fill in these charts. So if it's degree 0, the polynomial, that is called a constant. So put the word constant. So maybe make that a little bit smaller. All right, if it's first degree, if the degree is 1, it's called linear. If it's second degree, it's called quadratic. If it's third degree, it's called cubic. If it's fourth degree, it's called quartic. If it's fifth degree, it's called quintic. And if it's beyond that, like if it's sixth degree, you just say it's sixth degree. If it's seventh degree, you say it's seventh degree. All right, so there's only special names for the degrees 0 through 5. And then you can also classify the polynomial not only by the degree, but also by the number of terms. So if it only has one term, we already know that it's a monomial. If it has 2 terms, it's called a binomial. If it has 3 terms, it's called a trinomial. If it has 4 terms, it's just a polynomial. If it has 5 terms, 6 terms, 7 terms, it's just called a polynomial. Now, technically, a trinomial would also be a binomial. All right? So if it has 3 terms, it's a polynomial still. If it has 2 terms, it's a polynomial still. Polynomial really means more than one term. If it's only got 1 term, though, it's definitely a monomial. So then on these last couple, we just got to classify them by the number of terms and by this naming them by their degree. So look at number 8. Number 8, let's see. Let's write how many terms? And again, terms are separated by addition and subtraction, so there's how many? 2 terms. And then the degree. What's the degree on that? What's the highest power on the variable? What's that? Yeah, it's a 3. So then you just go up there in the chart and read it off. So if it's degree 3, it's called cubic, right? I'll put this where you can see it, I guess. So if it's degree 3, it's cubic. So this one would be a cubic. And it's got 2 terms, so it's a binomial. So that one's a cubic binomial. Again, if it's got 3 terms, it's cubic. So I'm looking at these charts. If it's got 3 terms, it's cubic. I'm sorry, I'm saying the wrong thing. If it's got a degree of 3, it's cubic. So it's got degree 3, so it's cubic, and then it's got 2 terms, so it's binomial. Or it's a binomial. All right, let's do this number 9. So what's the degree on 9? Yep, it's a 6. So that's the highest power, or that's the highest degree monomial. So the degree of the polynomial is 6. And then how many terms does it have? Yeah, it's got 1, 2, 3, 4. so it's got 4 terms. So again, now we just go up in those tables and read off the names. So if it's degree 6, well, again, degree 6 doesn't really have a special name. You just say it's a 6th degree polynomial. And then if it's got 4 terms, again, it's just a polynomial. So if it's got 4 or more terms, we're just going to call it a polynomial. So we're just going to say this is a 6th degree polynomial. So we're going to name it as a 6th degree polynomial. All right, and then they do have one story problem on here. The story problem, it says that this function right here, this h of t function, that represents the height of a, what did they throw off? It says they threw a chapstick off of the Golden Gate Bridge. So this h of t function right there, this height function, that represents the height of the chapstick off the water after t seconds. So all you guys got to do on this one is it says, really not a story problem. It's after a time of 3 seconds, so t is equal to 3. You're just going to take that 3 and you're going to plug it in or substitute it in for t right there. All right, so then that's just going to give us a height function. It looks like this. The height after 3 seconds is going to equal negative 16 times 3 squared plus 220. Now, what do we do? Do we do the exponent first, or do we do the negative 16 times 3?
The exponent first.
Yeah, you got to do order of operations. I can't see my mouse on the screen there. Where is it? There it is. Yeah, you got to do the exponent first. So don't multiply negative 16 times 3, okay? You got to do exponents before you multiply by order of operations. So we're going to do the 3 squared first. So what's 3 squared? Yep, that's 9. So we got negative 16 times 9 plus 220. So then the height after 3 seconds is going to be negative 16 times 9. That's a negative 144 plus 220, which would equal, I think that's 76. And the height here in this problem was given in, it was given in feet. So the answer would be 76 feet. So after 3 seconds, the chapstick is 76 feet above the water. And I think that's all of it, isn't it? Nothing else on that page? What about the next one?
Yeah, no,
That's it. So let me stop this recording.